Assalamu alaikum. Bismillah ar-Rahman ar-Rahim. In this module, we will discuss mechanical properties of materials. We may say the mechanical behavior of materials. It is very essential for the engineers to know the response of the materials under various loading conditions. Loading conditions means applications of mechanical forces. Force in which we make direct physical contact with the body is known as mechanical force. Now application of various loading conditions are the various forces in terms of the direction. We will discuss by taking few examples. Let's say we have a specimen and the application of force is like this. The force is pulling in nature. So by virtue of this type of loading, the body experiences the stretching, expansion, or we may say extension. And these kind of loadings are termed as the tension. Now we take another loading condition using same specimen. The loading is pushing in nature. So due to this loading, the material experiences the contraction or compression. These kind of loading conditions are termed as the compression. Now take another example. In this, the loading condition or the application of force is like this. So here we have the couple of forces, means torque, this is the distance, d, and these kind of loading conditions are termed as the twisting or torque. Similarly, we take another example on same specimen but the application of force like this. Here the non-collinear forces but equal and opposite in direction, which causes break but a shear of the specimen, and these type of loadings are termed as the shear loading conditions. Now upon application of external forces, external mechanical forces, the molecules of the body resist to any change, and due to these resistive forces the stresses are produced within the body. Now the easiest and the quickest way to know the several mechanical properties of the material using universal tensile machine. In universal tensile machine, this is one of the universal tensile machine in which the specimen is fixed between these two jaws. Now these are the jaws and the specimen is fixed in these two jaws, and the stress strain behavior or the curve is plotted using these computers. Now as far as the specimen dimensions are concerned, as per ASTM standard, E8, the specimen dimensions could be like this. Now in this is the gauge length which is marked, this is the gauge length which is marked, and this is the gripping section where we can simply use this section to grip into the jaws of the machine, or we may have hole in the specimen to use pin for the holding of this specimen. Further, you can visualize that here instead of having the sharp cut, we have some curvature so that the additional stress concentrations are not produced in this material, and we know the exact stress and strain behavior of this specimen. So this is the gauge length. Further, the specimen may be of circular cross section like this, or maybe the rectangular cross section, and this circular cross section specimen also termed as the button head specimen, and this rectangular cross section is also known as the dog bone specimen. Now using these specimens we can calculate the stress and strain of this particular material. Let's say this is the same specimen and in this specimen the application of force by using these grippers in the jaws, if we are taking the loading of tensile. Now in this specimen, this is the gauge length L0, or the initial length of the gauge. Now as the force increases, the change in length from the initial length L0 to an instantaneous length L, it starts stretching. Now this is the elongation, the change in length. Once the material is under tensile loading, which is del L, L minus L0. Now further we can calculate the engineering stresses. These are instantaneous force upon the initial cross-sectional area of the specimen. Since stresses are denoted by sigma, instantaneous force is F upon A naught is the initial cross-sectional area. Similarly, engineering strains can be made by this expression, elongation divided by the initial length, that is the gauge length. So epsilon, the strains are represented with epsilon, is equal to del L over L naught, or L minus L naught, L naught, or further we can write this L over L naught minus 1. Now with this we end our discussion here. Allah Hafiz.